Alright, so in this video, I took just a small little toroid and I have made some wire that is like two strands twisted around each other. I've done this before, and it's interesting because they are very tightly wrapped, and they still have a pretty decently strong magnetic field, but yet they're twisting around. So that's what this is. Just the same thing, but I started here, wrapped all the way around, came back, and kind of a small transistor. It's a BJT, but it's able to handle it. Back to the 24-volt power output, and it's dead quiet. I'll move the light bulb a little closer so you can see that. Yeah, power it up. It's actually surprisingly bright. It's pulling about 30 watts. Almost maxing out the bulb. Well, not really. Getting close to maxing out the bulb. Just off that tiny little toroid. That's crazy. Nothing's getting too hot, surprisingly. I'm actually surprised how cold it is. Especially for running off just a small little BJT transistor. I think it can handle, I don't know, I have to look at it, but I think it's about 10 amps. These ones were 30 amps, so I'm going to try these next time. I got more coming, so I'm going to try it out with this little circuit I got here. But yeah, this is pretty cool. And as the transistor heats up, it pulls more power. You can tell now it's 34. 35. Yeah, it's starting to get kind of hot now. I think I'm going to take that other extra big toroid I have over here. I'm going to do the same thing with this, but I got some thicker wire that I did that with. And I'm also going to try this first as a coil and see what a joule tape does through this too. And I'm curious, I might just try this out first and then see how much power it pulls through these ones comparing to that one. Alright, maybe I'm going to do that next. Now I got the circuit running through these transistors, and there's increase in power, which is not surprising. So yeah, we are pulling 40 watts, almost 41, and they're cold right now because I just started it. Definitely more light, and it's just running through that tiny little coil and a capacitor in between. But yeah, this thing's pretty damn good. I'm kind of disappointed with the vortex coil at the moment, but and it's dead quiet still. Impressive. But also I am harnessing all the magnetic field inside the coil, so now if I had an inductor or a core inside the vortex coil that like this does, it would be a lot more efficient. Now if this didn't have if it had an air core, it wouldn't be as efficient. Only if I had a core I could throw inside the vortex coil. But I do have some ideas I'm going to try at some point. Pretty consistent. And they're not that warm. Surprising. I'm sure the resistor is pretty hot. Actually, it's not. Wow. It's not that hot at all. Now the coil's getting a little warm this time. Not hot, but there's a little temperature there. So the diodes are like cold, it's all cold. I'm actually surprised. Probably because there's more inductance inside the core that is more efficient, and that it's not creating as much I don't know if you'd want to say flyback to the resistor or the transistor and the resistor to that what's by heating it up or what. I don't know, I'm not really sure on that one. I'm kind of thinking that might be the reason why it is doing that. But yeah, definitely some improvement with this little tiny guy. But I do want to do more experiments with the vortex coil, just the fact that I want to see the difference between the coil set and the secondary coil set. Because I feel like with that pattern, you're able to reduce the power consumption on that coil that's going the opposite direction. I don't know, that's just my theory. So for the sake, just saying, you know, I'm powering this side, that's this coil all running that way, and then when I'm absorbing the power, that's the coil all running the opposite way. So the intersection between each coil and the magnetic field, they're not really like parallel with each other, so they're not getting, I mean, technically it should be less efficient, but it might end up being that way. But I don't know, I just feel like the net magnetic field is the same as what it would be if they were parallel, so it should be having less field interaction, which would have a less what am I trying to say? It should have like a smaller interaction, so it should be easier to power the other coil than it would be for it to just be parallel with each other, because there's direct connection. Where here they're not directly connected, but yet there's still the same net magnetic field going around the coil. I don't know if you understand, but like for example, if you look in the inside, the core itself in the inside is a lot sharper than it is on the outside, because as it gets to towards the inside, it's almost a square, versus out here it's more like it's less of a square than it is in here. Obviously you can see the size difference. So in here it's compressing the field than the outside of the coil. So the stronger field in the outside versus the inside. So the net magnetic field that's going to be concentrated here. And this is where most of the interaction is. And with that ozone production, it was practically all in the center than the outside. So that was my main focus on the vortex coils, because the interaction between the two different coils are not directly parallel with each other. So if they have the same strength magnetic field, they should have a same interaction, but yet it's able to have less of a load on the secondary coil. That's my theory behind that. But I'll cut that off for this video.